How you doing here? We're going to go through a step-by-step procedure to break down this voltage divider. Now these are what they call the load resistors, and this is the actual voltage divider right here. Resistor A, B, C, and D. Now each one of these resistors will have a voltage that's unique to it, but not separate from the rest of the circuit. So there's the Ohm's law and Watt's law we'll be using later on, but we start off first with Gustav Kirchhoff. Now he's got his start off first with his current law. His current law states that the sum of the current entering a node is equal to the sum of the current leaving a node. What that means is this is a node right here where there's more than one path for electron flow. We've got current coming up this way, current coming up that way, and it flows into this node from here, 10 milliamps if we can see right there, and 15 milliamps, right? Which makes 25 milliamps on resistor B. It then flows up to node 2. Coming into node 2 also is this load resistor. 5 milliamps comes up through here, joins with 25 milliamps right here, and makes 30 milliamps in resistor C. And we go here again, 30 milliamps comes up through resistor C, comes into node 3, it gets joined with 30 milliamps out of this load resistor, comes in that way, up here into here, and makes 60 milliamps in resistor D. Resistor D is in series with this entire mess. Therefore, the current through resistor D is line current. So the I total for this circuit is 60 milliamps. Okay? So we've solved that beautifully. Now let's go on. Let's solve the old voltage. We've got 90 volts across this and this. If I can pretend for a second, you guys, that this is my voltage leads for a voltmeter, and I slide 90 volts back this way, I'm going to have 90 volts off resistor A also. Okay? So same thing. Let's put a voltmeter right here. It says 150. We slide it back here on resistor A and B. We've got 150 volts. 90 here, that leaves 60 volts right there. 90 and 60 is 150, which equals perfect with Gustav's voltage law. Coming right here again with my voltmeter is 180. Slide it all the way back because there's no drop in these wires because it's virtually resistance free. So we've got 180 here, less 90, less 60 equals 30 volts on resistor C. Same thing goes here. 180 here. If we go up here, we go back, that's 270. Less 180 is 90 volts on resistor D. I like to circle my voltage drops to indicate that they're voltage drops. Okay? So there's my voltage drops on my divider. Now let's go. Let's start figuring out some resistance values. What's the ohmic value of this? Well, if we've got voltage and current, right? Voltage divided by current equals resistance. So 90 divided by 15 milliamp equals A equals 6,000 ohms or 6 kilo ohms, whatever you prefer. We come up to B, same thing. We've got a voltage on B alone, which is 60. We've got a current on B, which is 25 milliamps. 60 volts divided by 25 milliamps equals 2,400 ohms, or 2.4 k ohms, right? Same thing. C, the same thing we'll do there. 30 volts, 30 milliamps equals 1,000 ohms, or 1 k ohm, right? D equals 90 volts, 60 milliamps equals 1,500 ohms, or 1.5 k ohms. Okay? So there, we got our resistance, we got our voltage, we've got our current on all these. Now it says, let's find the power used by resistors A, B, and C. So this is what we want to use for power. Voltage times amperage. So let's go back here. Amperage is 15 milliamps, which equates to 0.015 amps multiplied by 90 volts equals, so this one is 1.35 watts. I agree. Same thing here. 60 times 2.5 equals 1.5 watts. This one right here is 30 times 30 milliamps equals 0.9 watts. This one right here is 90 times 60 milliamps equals 5.4 watts. Okay? So there's the wattage of them 4 resistors. Let's go back over there. They want the wattage of these load resistors. 1, 2, and 3. We can jot them down nice and easily. Same things. Amperage times voltage. Amperage times voltage is all we have to do. So let's go to 0.9 watts. And I'll just drop them down here. 0.75 watts. And the last one is 5.4 watts. Now you can add up your power by P1 plus P2 plus P3 plus P4 and so on and get your P total. Or you can use these for here. You can use 60 milliamps times 270 volts equals 16.2 watts total. Okay? So there we've broken that entire circuit down. We've gotten everything we need to know about it, right? And everything, and if you ever notice this, you guys, whenever you're figuring out, just like series parallel, anything we do, and particularly when we start tomorrow on voltage, Edison 3-wires, everything kind of hooks and flows together. One mistake in here, and it'll screw up everything past there, and you know you got to go back and find where that mistake is. Anyway, the best of luck to you. I think there's about 4 or 5 of these. Go ahead and try them. If there's any questions, call me.